Now that we have a good idea about how the new input-output instruction is going to work, let's actually go ahead and we'll build it. Now, the first thing we want to do is actually build a couple of circuits which will act as an input to our CPU and an output from the CPU. So we're wanting to get a couple of circuits on this level here. Now, we'll call one of the circuits an input circuit. So this would represent, for example, a keyboard. So don't get confused here. We're calling it an input circuit, but the data is going to come out from it into the CPU. Okay, so it's an input circuit, meaning you're typing stuff in like a keyboard. Okay, so it's like the keyboard coming in to the CPU. We'll also have an output circuit. Now the output circuit will be like a monitor. The information will be coming out of the CPU and it will come into this output device. So those are the two devices we want to build, and we'll go ahead and we'll do that now. Now if you go into main, we'll build the circuit here, and I'll just talk you through the first circuit, which will be the input device, and then I'll show you the output device. So first of all, we want to be able to address this device. So we're going to have an input coming to it from the bus. So this will be the 8-bit address that will come out of the CPU, and it will go to every device. But whenever it gets to this device, it has to do something special to let it know that this is the device it wants to talk to. So if we'll make that face west, and this can face east, all the way around about east, and then west. And we can just call this, I'll just label it, let's say it's label it in underscore ADDR. So this is the input address, and of course it's going to be an 8 bits. Now, in order for us to ensure that we only talk to this one device, there's a simple way that we can do that. We could take an AND gate and we could make it an 8-bit AND gate, and then we could take 4 of these inverters and we could position them, say for example here and here. So we could position them like this here. Now it would be up to you exactly how you want to position these. So this is you giving a device a unique address. So in this instance here, we're going to have an address for this device, and the address is going to be, well, we're going to get a high output here whenever we get a value of 1111 and then 0000. So 1111 0000 is going to be this address for this device. So it would be 1111 and 0000. So whenever we put this particular address onto the bus, we know that we're going to be talking to this particular device, and we're going to have a connection between these two. So let me go ahead and I'll build this up for us. So now that we have our circuit here, which will let us address a particular device, what is it we want to do with this input and output device? Well, we want something that's going to represent, for example, a keyboard or a screen. But at its most simplest, all a keyboard or a screen is going to do is take individual bytes, one at a time, in and out of the CPU. And all we need to do is simulate that by just one single byte. And we've already got a circuit up there that we can use. So we can use the circuit here, which is a CPU register underscore 8. And that's our 8-bit register. Now the 8-bit register is going to have our set. We're going to have an enable. and we're going to have the output, we're going to have the input, and we've got our reset here, and we've also got the pin here just to take a copy of the value that's held in the register up to the higher level, just so we can see exactly what's happening. Now we're also going to have 4 input pins. So if I make this input pin here west and east and west, east and west, and we can call this pin our IO underscore clock underscore enable, and I'll take Control C, Control V, Control V, Control V, and we're also going to have our reset pin as well. So we'll just put a reset pin up there. So this one here is going to be IO clock set, and we're also going to have our input output pin. So that's going to be our I underscore O, and we'll have our data and address. So we'll have this one will be our D underscore A, and we're going to have the reset as well. So we'll just call that one R for a reset. So we have to connect these pins into this in some way in order to generate that functionality. So the first thing to note here is that we just have to follow the truth table. And if you remember, this is the truth table here. So the IO pin 00 is input data, 01 is input address, 10 is output data, and 11 is output address. So you can always write that down somewhere as we have worked through this video as a reminder. So let's say we want to input the data into the CPU. Now, if we're inputting data into the CPU, we're going to be outputting it from this device. So that is, we're going to put information onto the bus from this device. So as for example, we're typing our keyboard, and at some point we're going to click the enable, and it's going to enable that information out of the keyboard onto the bus and into the CPU. So we're going to do that whenever our IO goes to 0 and our data enable goes to 0. So if you check the little truth table, you'll see that those are the 2 bits. So we're going to have that output here is going to be determined by the enable, because that enables the information onto the bus, and it's also going to come from here. So when both of those are 0, we're going to expect to find a high at this point, which will enable that information onto the bus. So we're going to have to put both of these through a little inverter, and also into an AND gate. So I can go east, in fact I'll go north, and we'll just stick it up here. Okay, so it's going to go through here and here. So we would have to have a 0, 0 here to get the 1, 1 here, but we're also going to only do it whenever the clock enable has gone high. So this is the clock enable here. So when all of these 3 here have gone high, so example, I put a high here, then we're expecting to pass the information out of the keyboard, we'll call it a keyboard for the moment, out of the keyboard onto the bus and into the CPU. Now, you can remember where we got this line here from. So if we had a 0 and a 0 for our data address and input output, then we would be in input data mode. So that would mean that we would have a 0 here, a 1 here, and then whenever we got to stage 5, we would have a high output here, and then whenever the clock enable came along, it would send out this enable pulse, and this enable pulse is going to go to the output of our device and enable that value onto the bus. And whenever that value gets enabled onto the bus, it also gets set into the register within the device. So that's how we get the information out of the keyboard, if we call it a keyboard, and into the CPU. So take your time and make sure you understand the process there. But of course, when we finish building it up, we'll test it and you'll see it working. So we're going to have our output device here, and I'll face this west, and that's going to be east. And we can just call this, if you like, we'll call it bus underscore out, because we're putting information onto the bus from here, and it's going to have to be an 8-bit. Okay, now we're also going to have an input device. Now our input in effect is just going to be, for example, a keyboard, but we don't have a keyboard here right now. We actually do have a keyboard, but we're not going to use it at the moment. We'll use it in a different video. But we're going to just make this face east and west, and this will be our input device, and we'll make it an 8-bit. So we'll just call this, if you like, call it the data in underscore in. So all we're going to do for the input device is just literally put the values in. Okay, so we can just put the values straight in to the input device. But what we'll do is we'll take this to the hierarchy further up and we can work with it from there. But in effect, this is our input. Now we're going to have our reset pin here as well. I think I'll put it actually up here, it's a bit neater. So we'll have a reset pin here as well. So we've seen how we can read the data out of this device into our CPU, but we still haven't covered this addressing. None of it's connected up yet. So what we can do is if we grab another little memory device here, and we'll connect the input for the memory device here. Now, what controls the address? Now, it gets controlled whenever we output an address from the CPU. So to output an address from the CPU, we're going to have one on the I/O line, and we're going to have one on the data address. So it's 1, 1. Again, check the little truth table. So if I take a copy of this and use this as another AND gate, then we're going to have a value of 1 coming from the data address and 1 coming from the I/O. So that tells us we're now outputting an address from the CPU to a set of devices, and we know we're going to choose this one particular device because the address we've sent out is this particular address. Now, whenever we do that, what we want to be able to do is just to set that in this little temporary register. So we set it with the clock set, and that's the clock set. And finally, we take this out and we can put it into the memory. Now also we have to do the reset here, so this is the reset. And finally, we can take the output from this here, and the output is going to have to head into the set. And that's our circuit actually built up now. Only one other thing, we're going to have to take an output here for the reg, and I'll make that east, and I'll make that west, and I'll just call it reg out. We'll connect it up here, and again it's an 8-bit. So that's our device completed. Just give me a wee minute I'll go and I'll tidy it up a little bit, and that'll be us finished with it, and then we can test it out. So let's test this out. First of all, we're going to start off with resetting. So whenever we reset, it will clear up any of these red lines. So we click on the reset, on and off, and that's us ready to go. Now we can take our input data as 11111, all the ones. So this is our keyboard, and we've put our values in to our keyboard. Now we're going to first of all have to address this device. So the first thing that's going to happen is that we're going to output an address. So when we output an address, we're going to have 1 on the IO and 1 on the DA. So that'll send these two high, and then we're going to have to wait until we've got the set coming from the CPU. So once that set comes in, it will go high. Okay, now it will go high and then it will go low, but before it goes low, we'll already have an address here from the address bus. So this address will be already sitting on the bus. So if we have, for example, 1111, then this address has come from the bus into this device, and we know it's for this device because this tells us, and it's set this line high. Now whenever this set then goes low, it's going to hold that little bit of data. So whenever that goes low, you'll see this gets held. So it doesn't matter what happens here, this can change to whatever it wants. It's still going to hold this little bit as set. So now that we've set that in the device here, we know we're talking to this device. We can then say, okay, we've polled you, we've talked to you, now send us your data. So in order to send us the data, we're now going to have to go into the input data mode. So the input data mode occurs whenever we get a 0 and a 0. So when we get a 0 and a 0 here, we're expecting now to get a value for 1 on the enable. That is, we want to enable this value of 1 through onto the bus. So if we go high here, that enables that line onto the bus. Now once that has been enabled onto the bus, which is in stage 5, it's going to have to be set in Reg B. And of course, whenever you look at the connections in the control unit at stage 5, this gets enabled onto the bus and the Reg B gets set. So it'll take this here and it'll put it back into the CPU. So I think that's enough for this video. In the next video we'll have a look at the output circuit and we'll build up the hierarchy. So thank you for listening. I'll get you in the next video. Goodbye.